Leo, can you hear me?
Yes.
Okay, so Leo, what I wanted to say is that to continue, there is a software firewall and there is a hardware firewall. And typically, if we have a big company, it doesn't make any sense to actually use a software firewall. And also, the software firewall is weaker, much weaker than the hardware firewall. So there is certain kind of attacks that the hardware firewall is designed to handle. So it means that when we have a lot of packets, especially for a big company, so the hardware firewall is designed to handle that kind of packet inspection. So they inspect even every data packet. Did you take before or have you seen, let me see here if I really put, I think I already put it for you. I wanted to share that with you. Yeah. Did you see that form before? So this is how packet switching is done actually, or how I would say information is sent from device A to device B through the internet using the packet switching technique. And who is doing the packet switching is TCP/IP protocol. Did you see that something like that before?
Yes.
So do you understand it, right?
Yeah.
Perfect. So the ability to inspect the packets, that is, so imagine that this is a company here, that this is a company and the packet is coming here. So the ability to inspect packets at high speed is available to the hardware firewall, but not the software one. And also there is certain kind of data attacks that like DDoS. So this denial of service attacks that is produced by hackers, they send a lot of requests or information to actually a certain server. So if this server is not protected by a hardware firewall, it will go out of service. So the intention of this kind of million requests that goes to the web server is to make the server is not able to handle all the requests at any time. So putting a hardware firewall is able to handle that and is able to protect the server or the network behind it here. If this is a firewall here, everything here will be protected. Every server here will be safe, protected by the hardware firewall. Did I make sense so far? Did you understand what I'm trying to tell you?
Yes.
Excellent. Okay. Okay. So yeah, this shows you here the hardware firewall and the software firewall. Sometimes both of them is used in certain networks, but that's not the most common. Mostly big companies will have a hardware firewall instead of installing this software firewall on every PC. Let us move to the next. This is listing the advantage of a hardware firewall. And so again, the standard answer talks about software and hardware firewalls. This is a standard answer for the question that we have seen. Let me see if we still have something else that we would like to deal with here. Let me see. No, that's done. So one thing that we would like to talk about in compression, so certain kind of compression, when you use it, is lossy. It means that when you try to uncompress the information that you already compressed and restore it back, if it is lossless, it means that it will restore the information exactly like it was before compression. But the lossy one will actually produce smaller size packets or information or data but when it is restored, it will never go back to its original format. Does this make sense to you?
Yes.
Okay, let's move here to the next question. Let me see. Okay, what is the function of a web browser?
A web browser enables someone to access websites on the internet.
Okay, excellent. What else?
It's just just accessing websites. That's about as far as I know.
Okay, perfect. So have a look at this diagram. Can you tell me what you understand from this?
Yeah. So it's showing like I guess like the interaction between the web browser and
Web server.
the web server.
Excellent.
So on the client side, so that would be the user through the web browser. It makes a request to the web server through HTTP, and then the web server responds through HTTP along with the HTML, CSS, and JavaScript files on the server side, which the browser then like executes the JavaScript and applies a CSS, where the CSS is like it's what how do I describe it? It's what gives like the visual features, a lot of like visual aspects to the websites.
Okay, so we can say that one of the descriptions that we can say for the web browser of functionality is that it actually reads HTML and displays the content to you in a readable format. Am I right?
Yes.
Okay, and its job is to send the HTTP request. Do you know what is the HTTP request?
HTTP request, just like a request being made to the server
Okay,
through the
so
browser.
this HTTP is actually initially, so there is something missing, but this is only a diagram for simplification. So HTTP request definitely does not go to the web server directly. So it goes to something called DNS. Okay, so this DNS on the internet is actually, so let's say you want to enter google.com. So Google, the word google.com actually have no address on the internet. So what the internet is operated through is IPs. You know what they mean an IP, right?
Yes.
Okay, so everything, every website, every web server is actually have an IP. Okay, so the DNS have tables inside it. So inside the tables, there is a database. So that will see, okay, we are able to check every URL or every name, website name like that, it corresponds to which IP. And this IP is returned back to your web browser. And then your web browser will internally, without you knowing, send a request to that IP, which is, of course, it's a server. So the server then will respond with HTML information. But if you write just Google and the DNS is not working or not set up properly on your internet, you will never be able to reach any web server because your web browser does not know the IP address of the web server. So you're not able to reach anywhere. Okay, you need first a DNS. Does this make sense to you?
Yes.
Okay, excellent. So, okay, now we already talk about browsers. Yeah, now, so tell me two application of queues in computing. So it seems that Q is really appearing so fast and a lot in sorry, not so fast, but even in paper 1 and paper 2. Sorry. So are you able to remember?
Yes. So queues, first of all, is used in task management for CPU in terms of computing.
Okay, excellent. What else?
Another would be scheduling.
Okay, so I would say yes, you said CPU scheduling, it's also possible. So let us have a look at the official answer. We talked about something similar before. So print queues. So if you have a shared printer, then definitely everybody will be sending his document to the queue. And definitely the first person who sent, so this is document A, and this is the queue, this is document B, and this is document C. So we expect that the one that first come is the one that is printed first. So that's why the queue is suitable for that. CPU task scheduling. So if I want to schedule task, the first task that I put in the queue is the one that should be first executed. So all this is possible. Handling interrupts. We can talk about interrupts later. So the buffer for devices like keyboard. So when you press a character on a keyboard, so you imagine that you press 5 characters. Which one should be printed first? The first one that you printed. If you press here character A and then Z and then F, so you expect A to appear first on the screen, or to be even printed first on the screen. So that makes sense, right?
Yes.
So again, also that happens in the routers and switches. So information or data packets that arrive to the routers, first it should be the one that is dispatched out first. So if it comes first, it should be handled first. Okay. Mail queues also the same. If you are having a mail queue, it means that you are sending maybe 5 or 10 emails at the same time. Then the queue should be able to handle the first email that comes in first, and then it maybe display it or send it to the receiver. So if there is a queue like that with the amount of emails that is coming, so we should handle the one that comes first at the start. Am I right?
Yes.
Okay. And if we want to give a physical example of physical queues, we talk about customer waiting in line in supermarket, call centers. The same happened to like that. So if you call a call center, and you expect that if you call first, then you should have the service, or you should be attended first. Am I right?
Yes.
Okay, perfect. Okay, are you able to give? Do you know what is the meaning a Unicode?
Unicode, yeah. So Unicode, it's a format for like characters.
Excellent, excellent. And why we need to use it to represent data in computer system?
Well, because like I guess pure data is just like zeros and ones, which generally like isn't comprehensible. So a format like Unicode is required to show things in like in a format that's like more understandable.
Perfect. That's a good answer. But why Unicode and not ASCII, for example? ASCII
Well,
also.
yeah.
Yeah, tell me.
Well, Unicode has like a larger available range of characters, including those from like other languages as well, which makes it more universally accessible.
Excellent answer. Yes, that you already nailed that answer. Yes. Okay, so that is a Unicode, and yes, but you already nailed it. So outline what is meant by a collection.
Collection,
Mm-hmm.
like it's like a group. I guess it's like a I know it's like a kind of like group of data, but I'm not sure like exactly what it like signifies, I guess.
Okay, so let's have a look here. A collection or a data structure. Huh? So a collection is a data structure. Uh, Groups many values under a single variable name. So it allows you to add data, retrieve data, iterate through the data. Okay, and what could be an example of a collection? So have a look here. So arrays is a collection, linked list is a collection, stacks and queues is a collection. Does this make sense?
Yes.
Okay. Okay, and there is more important information here. So this table is actually extremely important because I have seen it many times here. So you need to know that the IP collection method specifically for this IB exam, you need to be aware that, and you need to mention in your answer that collection have methods like add item, get next, reset next, has next, and is empty. So this is a theoretical answer. We didn't try that at all in the programming wise, but in theory, that's how it works. So add item, I think we add an element to the end of the collection that contains the argument. So this is adding an item to the end. Get next, so it will return the first item in the collection when it is first called. Reset next means restarts the iteration through the collection. The two lines shown will retrieve. So if you reset the connection and get next, this will give you the first item in the collection. So reset next, if you are iterating through how to say a collection, and then maybe you reach the middle of the collection, reset next, it means that it will bring you to the start again of the collection. Does this make sense? Is it
Oh
difficult?
yes. I know it's fine.
So has next, it's actually return true if there is one or more elements in the collection. Okay, is empty, we note. I think it's clear, right?
Yes.
Okay, so let me see if there is other part of the answer that we need to clarify. I believe no. Let me confirm that. No, there is no more part of the answers. That is okay. Okay, now have a look, please. A computer science student is coding and running a program while several documents such as essays, tab repos, and homework are being printed out. Define the term queue as a data structure.
A queue is a dynamic data structure, meaning that its size is able to change. That is first in, first out, uh, which means, yeah, that's about as far as I
Yes,
can
but
describe
please
it.
just be aware that we learn to do two things. We learn to do dynamic data structure and static data structure. So you are able to actually use both. So don't only mention dynamic as the only one. So it is, yes, it's a data structure that we are able to save information in, first in, first out. Yes, you give an example, also can, but don't say it is only dynamic. It can be dynamic. It's based on the implementation. You can implement it as a dynamic, and also you can do it as a static. Is it fine like that? Is it clear?
Yes, yes.
Okay, in this context, in this scenario, give a two different queues, two different example of queues in this kind of scenarios that he's doing.
The different queues used in this specific scenario. Uh, well, a queue would be used through the printing of the documents, since since the first document that's put into the queue would be the first that's printed out.
Okay, but he is telling us two different queues. This means that not the one about printing. So he is doing coding and running a program. So let us have a look here. So see here. Okay. So he talked about print queue, and he talked about keyboard queue, and he says that the examiner will accept any other job queue like a program is running. So if a program is supposed to run, so it will be stationed in a queue, and it will take its time to be executed by the CPU, right? So that is
Yes.
also another possibility of a queue. Now let us go to the next. Okay, now a company has a local network, an Ethernet connection. The LAN is accessible to all the employees through their personal accounts. At the office, employee can use either desktop computers or for wired access to the LAN, or personal laptops to connect wirelessly. Identify one additional hardware component in a wireless LAN.
Okay. One additional hardware component in a wireless LAN. A router.
Excellent. Can you give a definition of a router?
A router is a device that, well, as like the name would suggest, it routes I guess like data through the, let's say
So, okay, now, no problem. It's okay. I will explain that. The purpose is not to make you feel sad that you cannot recall. My job here is to help you to remember. So don't feel sad if you don't know how to answer. We still have plenty of time to be able to go through more exam questions. You are an excellent guy. No, truly, I'm not just complimenting you. So the job of a router is actually to forward data packets between different IP addresses. So if you have an internal network, a group of computers, do you know what is a switch or a hub?
switch and a hub.
A switch or a hub?
Yes. Switch. Yeah.
So let's say a hub. So if you have here, we can put a router. I did put a picture, but I am not very sure where is it at the moment, but sorry for that. So if you have an internal network, let's say in your home, you have maybe 5 or 6 PC. Every person in the house have his own PC and even a laptop. So you use to connect the internal network using a hub or a switch. And then if you want to connect to the internet, here, internet, okay? So you use a router. Inside the internal network, you're able to communicate together. You're able to print document on the network printer. Maybe you have something like a network storage that is shared inside the internal network. This is a storage device that is only connected using a cable to the switch. Every PC here are able to share information and documents on this storage, network storage. And then you will find that there is a local IPs here inside the internal network, and the router is actually connecting to the internet through the ISP. So the internet service provider, when you pay it, it will do some setting on your router that allow your router to connect to the ISP and get a public IP. Okay, public IP is actually different from a private IP. Inside here, inside our internal network, we have a private IP that is used only internally. But to be able to connect to the internet, we need a public IP, and we cannot guess or use or get an IP unless we pay for the internet service provider to give it to us. Okay, so again, to route the information or the data packets from our internal network with the private IP to the external network, which is internet with a public IP, we need a router. So forward data packets between different IP addresses. Okay, most probably you will find the public IP starting with 10, 1, and maybe something here. And most of the internal networks start with 192.168, and then whatever inside here. But typically they start with this kind of. So this is totally different to IPs. You cannot communicate or send data between them without a router. Does this make sense? Okay. So another component is actually access point. So another wireless component is an access point. What is an access point? Example of an access point is a wireless access point. So it can be a small device like that, like this, that allow people to connect wirelessly to the internet or to even to the network, to the internal network. And the router here, this is a switch that have one laptop connected to it. These two laptops connect wirelessly to this access point, and access point is connected with a wire to the switch, and the switch is connected with a wire to the router, and the router, some router are having a modem inside. So maybe inside Malaysia, typically we don't have modems, we have router and modem in the same device. And in short, this router is able to connect to the ISP or internet service provider, telecom or whatever companies that we are using to connect to the internet. Does this make sense so far? Did I manage to make it clear to you?
Yes.
Okay, so gateways. So gateways also is in your syllabus. So imagine that two different networks that is using different protocols. Just be aware, you only need to know just like that only. So a protocol, an example of a protocol is a TCP/IP. If there is a network that is using something other than the IP, the TCP/IP, we want to connect both together, we have to use a gateway. So gateway connect networks operating on different protocols. Okay, so it acts as a translator between dissimilar networks. Is that clear? We can proceed.
Yes.
Okay, so the ideal answer that is provided: a wireless router, access point, a bridge or a repeater, a controller, a wireless adapter. Do you know what is the meaning of a wireless adapter?
Yes. Yes.
Okay, you know what is the meaning a network interface card?
Yes.
Perfect. Good answer. Okay, we already answered that. Sorry. Let me see. Yeah. So, okay, now distinguish between a wired network and a wireless network in terms of reliability. So you have to give me something to, like a comparison between a wired network and a wireless one, just only on a reliability of transmission.
Okay. A wired network, because a physical connection is involved, tends to be more more reliable in that regard. However, this also means that for a wired network, if there is a physical damage done to the physical connection, then that can cause issues with transmission in that regard.
Okay, that's a good answer. Let me see here. I think I no need. There's no much. So the reliability here depends on the strength of the wireless signal. So if you are far from the router, definitely the wireless signal will be weaker. So definitely it means that you have a slower data transfer if you are using a wireless and you are far away from the router. So we depend on the wireless signal. But with the Ethernet, the, the, the strength or the signal does not depend on the distance. Am I right? So,
Yes.
and the wire is immune to the interference. So typically, if you have a wireless and there is a lot of electromagnetic signals that is near the wireless, that affects the transfers and the speed of the connection. Okay. But with the internet cable, there is nothing like that. But except that what you mentioned now is actually correct, which is when the Ethernet cable is cut or broken, it will affect the reliability.
Yeah.
Okay, now we want to know when we have a look here, outline why a wireless network may be less secure than a wired network.
A wireless network could be less secure than a wired network because to connect to a wired network, you need to actually like have a physical connection. Having physical access can be more difficult than in the case of a wireless network, where you could be able to access it without needing that.
Okay, so the security wise here, it is more serious than what we try to actually mention. So here, wireless network are less secure than wired one because data can be intercepted. So a hacker can act in the middle. So he will listen to all the packets and data transfer that is being flying in the air between you as a PC or laptop and this wireless router or even wireless access point. So it is very easy to intercept and even to say do kind of attack that's called a man in the middle. So this is a hacker and he listened to the password and all whatever you are giving to the server through the wireless because it's moving in the air, right? So everybody can intercept it. If they have the proper tools and proper hardware, they are able to intercept it. And it's not so difficult actually with the current tools available. So they are able to see your password and they are able to act as if they will look into the eyes of the server that it is you. Okay, if the server is for the bank, it's a catastrophe. But with a wire, that's not possible. The data is transmitted through a wire, and then if he cut it, then it's broken. I mean, he cannot do that. You have to gain a physical access to your house or to your place to be able to use wires. But with the wireless, he can even sit beside your house and he can even intercept your information. Okay.
Yep.
Okay. Let me see here. Network. Yeah. Okay. Employee is not in the office that can access the company resources over the internet. So employees who are not in the office can access the company resources over the internet using a virtual private network. Outline two features of the VN to make it secure.
Two features of a VPN that make it secure. First of all, its usage of encryption means that the data is not accessible to anyone except those who have the key. And another feature of a VPN that makes it secure is that uh, it hides like the actual location of the device from the ISP.
Okay, excellent. Can you understand anything from what you are seeing here? Okay. So
no, not completely. No.
no. Okay. So these two computers, this one and this one, they have a secure tunnel between them. This tunnel is in orange color. So a hacker is actually trying to send a packet and try to intercept the information flowing between both this computer, computer 1 and computer 2, or computer 1 and the server. He is not able to do that. So every time he tried to intercept, because the information is passing through a tunnel, so it's actually being thrown back to him, and he cannot see or intercept or even get the information that is being flown inside the secure tunnel. Does this make sense so far?
Yes.
Okay. Okay. Just let me highlight what you said about the encryption is actually correct. Another thing I would like to highlight to you, that authentication. So VPN do authentication. It means that it requires username and password uh, for actually the connection to be established in the first place. Okay, so not anybody can actually communicate or start using this VPN without authentication. Okay, same when you're logging into a page or to your email, you have to provide a username and password. Okay, can you explain now? So for me, other than that, you have actually I think you're already aware of this VPN, unless you have something else to tell me. Do you have any other
No.
questions? So
No.
now, please explain to me this data packet switching. Why? Because he asked it here. Explain how data is transmitted by packet switching. So can you please explain to me how is that done?
Packet switching.
Mm-hmm.
So how how packet switching works is like I know how it works, but I'm not sure how to like put it into words in a concise way.
No problem. It's okay. So this is two devices. Assume that they are having a video or voice conversation. So this voice conversation, uh, it means that it generates data that need to be sent from computer A to computer B. Okay, and so the data is cut into small packets like that, and the packets are sent to routers, and these routers that we are pointing here from S1 to S6, this is, we call it core routers. This is the backbone of the internet. This is the routers that makes the internet operate. So it take information from one place to another. Using what? Using sender IP and receiver IP. So using these two information, it will take the information, the data packet from you, and the first router will start to dissipate the packets and cut it into different directions. And so based on the utilization, how utilized and how is the traffic on every router, they will send it to the next one. Maybe they decide the fastest way is that packet 4 and packet 1 go separate ways. And so every router will keep sending the data packets to the next router until it reaches near its destination. And this router will send the packets in this order. This order is different from that one. Here 4, 3, 2, 1. Here arrive in 2, 4, 3, 1 because of different speeds of the routers. The job of this device to actually arrange the packets back. It's about to finish the session. If we didn't finish it, I will complete